What are the different amplifier classes in signal processing? Imagine trying to make a whisper louder or a musical note clearer. That's what amplifiers do in signal processing and control systems. They boost weak signals so they can be used effectively. But not all amplifiers work the same way. They are categorized into different classes based on how they operate during each cycle of the input signal. These classes balance efficiency, signal fidelity, and application needs. The first type is Class A. This amplifier conducts for the entire input signal cycle, which is a full 360 degrees. It uses one active device, like a transistor or tube, to amplify both the positive and negative parts of the waveform. Because it conducts all the time, it produces very little distortion, making it perfect for high-quality audio. The downside is it's not very efficient. It wastes a lot of power as heat, usually between 25 and 50%. Next is Class B. This type uses two devices that work together. Each conducts for half of the cycle, so one handles the positive part and the other the negative. This setup improves efficiency to around 75%. But because each device turns off and on at the zero crossing point, it can cause a small glitch called crossover distortion. This makes it less ideal for audio but great for radio frequency applications. Then we have Class AB. This is a mix of Class A and Class B. Both devices conduct slightly more than half the cycle, overlapping a bit to reduce crossover distortion. This results in better efficiency than Class A, usually between 50 and 60%, while still keeping good sound quality. It's often used in audio amplifiers where a balance between fidelity and power consumption is needed. Moving on to Class C, this amplifier conducts for less than 90 degrees of the cycle, meaning it's on for only a small part of the waveform. This makes it very efficient, often over 90%. However, it introduces a lot of distortion, so it's not suitable for audio signals. Instead, it's perfect for radio frequency applications like transmitters, where the signal is filtered and tuned to a specific frequency. Finally, there are switching amplifiers like Class D. These operate the active device as a switch, turning fully on or off. They use pulse width modulation to control the output, which makes them extremely efficient, often above 90%. They're popular in digital audio and power-efficient devices because they waste less energy and produce less heat. Other classes like E, F, G, H, and T are specialized versions designed for specific high-performance needs. In short, the way an amplifier conducts current during each cycle defines its class. This affects how well it amplifies signals, how much power it uses, and how much distortion it introduces. Class A gives you the best sound quality but uses more power. Classes B and B are more efficient but have some distortion. Class C is very efficient but only for specific radio signals. Switching classes like D focus on saving energy, especially in digital and high-power applications. The right choice depends on what you need, whether it's crystal clear audio, power savings, or radio frequency transmission.